Hi everybody, welcome back. So I have a little joke for you. You know why plants don't like math? Because they're afraid of getting square roots. So yes, we're going to continue studying square roots and using them to solve quadratic equations. There are two important properties we'll be using. First, it basically is the square root preserves products and quotients. So if a and b are integers or any non-negative numbers, the square root of ab is the square root of a times the square root of b. This is basically because if you square this number, you get a. If you square this number, you get b, and you multiply them, you get ab, which is exactly what you would get if you squared this. And then similarly, as long as b is not 0, square root of a divided by b is the square root of a divided by the square root of b. All right. That only works for multiplication and division. In particular, the square root of a plus b is not equal to the square root of a plus the square root of b. This is almost never true. Okay, so keep that in mind. All right. So to do this, we can kind of simplify these expressions, and by simplifying, we can because a lot of these numbers are multiples or can be factored in a certain way. So we can actually replace these expressions with something involving square roots of much smaller numbers. So for example, square root of 18 of course is 9 times 2, which is the square root of, well, we can write this as the square root of 9 times the square root of 2. And then the square root of 9, we know it's a whole number, it's 3. So this is actually 3 times the square root of 2. Okay. Square root of 50 is the square root of, what, 25 times 2, right? You can factor it this way, and then this will be square root of 25 times the square root of 2, which is 5 times the square root of 2. Notice that if you wanted to do this a different way, you could have also said this is 50 is 5 times 5 times 2, and you would have gotten the same thing. You would have said that this is 5 squared. Greater square root of 5 squared is of course 5. So this would be the same thing. Square root of 7/9, we can write this as the square root of 7 divided by the square root of 9, which is the square root of 7 divided by 3. And we can't really do anything with the square root of 7 anymore. We could do anything with the square root of 2 because those are prime numbers. And the square root of 24 is we can write 24 as 2 times 2 times 2 times 3 over 7. Well, this is 2 times 2, that's 4, so this would be 4 times 6 over 7. And we can write this as the square root of 4 times 6 over the square root of 7, which is the square root of 4 times the square root of 6 over square root of 7, which is 2 square root of 6 over 7, square root of 7. And just between you and me, it would be okay if you left it like this, but sometimes they want you to what we call rationalize the denominator. If you have a square root in the denominator, you'd like to get rid of it, and you can do that by multiplying and dividing by the square root of 7. So this would be 2 times the square root of 42 over 7. I don't know if this is actually any nicer than this, but I'd accept either one. Okay, but when you're doing these problems online, pay close attention to the directions, because they might not want you to have any square roots in the denominator. All right. Okay, and so with this, now we want to just start by solving some of these quadratic equations. These are quadratic equations. Of course, are they involve setting a quadratic function equal to a number. And we're going to get started with the real simple ones. About the easiest you can get is something like this, where x is a number. If you square it, you get 59. So x has to be plus or minus the square root of 59. Okay, and we won't worry about the approximation to this right now. but you'll notice that there are two solutions. So actually, this actually means x equals the square root of 59 or minus the square root of 59. Okay. Sometimes here, this is almost as easy, x squared minus 17. You just have to add 17 to both sides, and then take the square root. So x would be plus or minus the square root of 17. So, yeah. In this one for part C, again, we have to do one more thing before we take the square roots. We'd really like to isolate this x squared and then take the square root, so we can get rid of this 5 by dividing both sides by 5. And we get x squared equals 12/5, and then take the square root of both sides. Okay. And we won't worry about rationalizing the denominator right now. So it'll just be that. So the two solutions would be this. For part D, if we have something like this, here we would like to get rid of, really isolate this x squared, but we have a 9 and a 6 to get rid of. And because this is 6 something minus 9, we can always, let's take care of the 9 first. It's real important we take care of the 9 first. So we add 9 to both sides. And we get 6x squared is equal to 9 minus 5, that's 4. And now we can divide both sides by 6, and we get x squared equals 4/6, which we can reduce to 2/3, and then take the square root of both sides. And so this would be, x would be plus or minus the square root of 2/3. Okay, so you get two solutions. All right. Look at some more examples. And again, you might need to rationalize the denominator if your computer does it. Again, I won't. If you're doing this like a take-home exam, you won't have to worry about it as far as I'm concerned. Okay. Now let's look at part E. Now here before you feel the temptation to multiply this out, notice that if we know what x plus 2 is, that's almost as good as knowing what x is, because we can always just subtract 2. Once we know what x plus 2 is, we can subtract 2. So we can take, say, x plus 2, take the square root of both sides, and then we'll get x plus 2 is going to be plus or minus the square root of 81. Well, the square root of 81 is 9, so this is the same thing as plus or minus 9. So we have two possibilities. Either x plus 2 is 9, or x plus 2 is negative 9. And if x plus 2 is 9, we subtract 2, and we get x equals 7. If it's negative 9, again we subtract 2, and we get x equals minus 11. All right? So that's the thing. So if you can see, as soon as you have like something squared on one side, you can just go ahead and take the square roots and then consider all the possibilities. So this one is similar, right? We can take the square root of both sides. This is plus or minus 4. So 2x minus 1 equal either 4, or 2x minus 1 is negative 4. In the first case, we add 1 to both sides. We get 2x equals 5. Divide by 2, we get x is 5/2. 2x minus 1 is negative 4. We add 1 to both sides again. We get 2x equals negative 3. So x equals negative 3/2. Okay. Encourage you to pause the video, maybe try the next two on your own. Okay, so what happens here, we take the square root of both sides, and we get x minus 1/2 is plus or minus the square root of 7. So either x minus 1/2 is the positive square root of 7, or x minus 1/2 is negative square root of 7. And then we add 1/2 to both sides. and we get 1/2 minus the square root of 7, or rather plus in this case, and over here it will be 1/2 minus the square root of 7, because if we add 1/2. Right? We don't need a common denominator. We'll just leave it like this. Here on part H, almost the same thing, except we have this pesky little 2 here. How do we do that? Get rid of it. Divide by both sides by 2. So we get x minus 5 squared is 13/2. Then take the square root of both sides. So x minus 5 is plus or minus the square root of 13/2. And then add 5. So that means x plus 5 is either the square root of 13/2 or x minus 5. We should get minus 5 here. So then add 5 to both sides. And you get x is 5 plus the square root of 13/2 or 5 minus the square root of 13/2. Okay. Last one is this one. Let's say again we have a 4 and a -3 we would like to first get rid of before we address the x plus 1. So we have a number sitting out here by itself. You always want to get rid of that by subtracting or adding. So you get -3 x plus 1 squared equals -3. And what do you know? We can divide both sides by -3. And then we get x plus 1 squared is equal to 1. Okay, and I think you can see that there's only one possibility. Well, actually, there would be 2 possibilities, right? Yeah, x plus 1 is, well, that would be plus or minus the square root of 1, which is plus or minus 1. So either x plus 1 equals 1 or x plus 1 equals -1. So this means x is 0. And this, if we subtract 1 from both sides, we get x equals -2. Okay, whoops, there we go. Alright, again, the best way to learn this is practice, practice, practice. And well, the one thing is, if you end up taking the square root of a negative number, we're not doing complex numbers or imaginary numbers. So if you do try this and you get a square root of a negative number, you either have made a mistake or there's no solution, no real solution. So that's all for today. See you next time.